First of all, again, welcome everyone to this Cosmoglobe kickoff meeting. I'm really happy to see so many have signed up and are joining us today. My name is Ingunn Wehus, and I will give a short introduction to Cosmoglobe. So to get started, let me flash you a familiar picture of the CMB as seen by Planck, and also an example of one of the foreground components, here the polarized thermal dust. And summarized in, so the Planck experience, which again, of course, is building of the experience of dozens of other CMB experiments, is sort of summarized in this plot on the polarization side, where we plot intensity or polarization as a function of frequency, and are plotting a few foreground components and the CMB. However, of course, this is a somewhat limited, it's the current state of knowledge, but it is also somewhat limited view. So if we zoom out a little bit of this plot, we see that there is potential for much more information to be added at various observations at more frequencies and L modes and sky coverages, and of course more foreground modeling, more components to be added, and so forth. And this is exactly why we are here today. We want to add as much information as possible, and here exemplified by all experiments that have signed up for this meeting. So what is Cosmoglobe? The main idea is simply just to integrate the world's best data from radio to sub-millimeter wavelengths into a single model through global analysis, which of course is a quite ambitious goal, but it should be noticed that it's built on well-established Bayesian parameter estimation techniques, as developed by Planck and later by Planck and implemented in Commander. So this is already demonstrated to work by Beyond Planck, which we will hear more about shortly. And the framework already allows for adding more and more data sets, either as base raw time order data, which allows for a maximal global analysis of all parameters, but also as sky maps that can be very useful for foreground modeling, component separations, and lots of other stuff. And of course, needless to say, this is a global effort. We are dependent on everyone wanting to do this for it to happen. And as will be clear during this meeting, and because this is a thing for the future, it's of course also driven by young scientists. We have an open science philosophy with a strong focus on collaboration. And finally, let me mention that exactly what Cosmoglobe will end up being isn't completely clear at the moment, because it depends on what's happening during the meeting this week and in the future. It basically depends on all of us and all of you. So let me just give a very short motivation of some aspect of the global analysis here by taking a step back and going through a classic linear CMB analysis pipeline, where we start out with some observations, and then we send these data into data selection and calibration. And then we do map making. After that, we do component separation. Based on those maps, we do power spectrum estimation. And based on that, we might do parameter estimation. And this is how CMB analysis has been done for a very long time, and also through a large part of the Planck history. Then towards the end of Planck, it was clearly realized that the sensitivity was now so good that we were driven sort of by degeneracies between, say, foregrounds and gain calibration, and we needed to do iterative data analysis by closing this loop and going through this whole chain a few times. And this was done for the final Planck release and for the NPipe release following. However, what was new about Beyond Planck was that this was no longer discrete steps with different codes, but now we ended up doing a fully joint analysis pipeline where all these steps were integrated into one code so that we can seamlessly do all steps. Of course, that takes away the possibility for human errors and long waiting times. But more importantly, or equally importantly, it also makes us able to map out the full uncertainties from all aspects of this together. So we get joint uncertainties, including both calibration, map making, and so forth. And this has been demonstrated to work using for the Beyond Planck project where we were reanalyzing Planck LFI data, which of course is a somewhat contained data set. So the next thing to do is to expand this and include more data sets, and this is what Cosmoglobe is about. So very shortly after this talk, you will hear about Beyond Planck, and then later today about the various some other experiments that we've already started looking on inside the Cosmoglobe project, just locally in Oslo. We have in parallel with and after analyzing Beyond Planck also started analyzing WMAP, Spider, Quiet, and Lightbird, which is just some examples, but together they span a nice exploration suite of both past, present, and future CMB experiments, and also both ground, balloon, and satellite CMB experiments. And you will hear talks about this later today after the break, which we hope will serve as a nice example of what can be done with Cosmoglobe. And of course, then the next step is to include even more. And that's why we're here in this meeting. So just briefly, I think I mentioned today, we will look at Cosmoglobe, how it started with Beyond Planck and how we have this example we had looked at locally. And then on Tuesday and Wednesday, we will hear presentations from all interested experiments. And there will also be lots of time for discussions about how to proceed. Similarly, on Thursday, it's set aside for foreground modeling, where we have joined forces with the PanX foreground modeling group. And there will also be ample time for discussions on Thursday. And then on Friday, we will try to bring together all the discussions from the previous 3 days and have more discussions of how to go in the future with Cosmoglobe, what we want to do, how to do it, and so forth. So we are hoping that you're all interested in participating very actively to this meeting and actually decide what we want to do with Cosmoglobe, at least start talking about it. So, as mentioned, this is the main philosophy for this meeting, just bring people together, start discussing how to proceed forward to get the best possible analysis cross-experimentally. And of course, we realize that people are very different, have very different goals and experiences going into this. And so we do want to mention that any level of involvement is okay. Of course, some of you might only be interested in Cosmoglobe as a community meeting area, while others will be interested in full collaboration, including code development. Some might mostly be interested in the end projects from this efforts, like using the Cosmoglobe sky model for forecasting and simulations. And others, again, might be mainly interested in providing input to this effort in terms of sky maps or foreground models or timelines or whatever. So whatever your motivations are, you are very welcome to join us in any respect. And thank you all for joining us today. And before I give the word back to Duncan, who is our main organizer and will give you more of the details for today, I just want to thank our funding agencies for making Cosmoglobe a reality, and especially the ERC funding from the EU. Thank you, and please.